Hello everyone, this is Nageshwara, Assistant Professor, Department of Civil Engineering from Nalla Narasimhareddy Education Societies and Group of Institution, Hyderabad. Okay, guys, today we will discuss one topic from Transportation Engineering of second unit, that is geometry, that is highway geometric design. This is the second unit. From this unit, we will discuss one topic, that is stopping sight distance, SSD, an important topic in second unit, and we will briefly discuss about this. So what is SSD? The minimum sight distance available on a highway at any spot should be of sufficient length to stop a vehicle traveling at design speed safely without collision with any other obstruction. The absolute minimum sight distance is therefore equal to the stopping sight distance, which is also sometimes called non-passing sight distance. Here, sight distance available on a road to a driver at any instant depends on and is the feature of the road ahead, height of the driver's eye above the road surface, height of the object above the road surface. So these are the basic parameters we need to take above all three conditions. And the distance within which a motor vehicle can be stopped depends upon the factors, and stopping depends upon the factor listed is there. This is below. These are the factors. So total reaction time of driver, efficiency of brakes, speed of vehicle, gradient of the road, and friction resistance between the road and tires. So 5 points we need to maintain, or we need to take the account of. So speed of the vehicle. So we should maintain the proper design speed when we are traveling on the road for the stopping sight distance. And here total reaction time of the driver. So reaction time of driver is the time taken from the instant the object is visible to the driver to the instant the brakes are efficiently applied. The amount of time gap depends on several factors. So here also I have two categories is there here. Perception time and brake reaction time we have here. And in the image we can say driver is dangerous. So this is a brake applied and here the car stopped. So the reaction distance, the driver sees there is a reaction distance. So in this gap, so when the brake is applied here, here the braking distance and here the object. So according to that we need to maintain. So here perception time in the sense, the time required for a driver to release the brakes must be applied. It is the time for the instant the object to come on the line of sight of the driver to the instant he realizes that the vehicle need to be stopped. The brake reaction time in the sense, the several factors including the skills of the driver and the type of problems and the various other environmental factors we need to take to the account. So next, friction resistance between the road and tires. So for example, in first picture is the wet road and second picture is the dry road. So depend upon the condition when we are applying the brakes, so it will be moving like this. So stopping distance is 1.5 times longer on wet roads and 3 times longer on ice roads. The gradient of the road, so we need to maintain some inclinations here there. Then only we are using. For in a flyover zone also, when we are using flat, then what happen? It will problem. So it is affected. So according to the gradient only, we need to maintain the design speed. So recently there is an incident is happened in Gachibowli flyover at Hyderabad. So that kind of problems is happened. Actually, the design speed is the 40 kmph, but the car is moving around more than 100 kmph. Then what happened? It automatically. So gradient on the road warning signs may be shown as the ratios are percentages. The ratio is 1:4. Steep hill upwards expected as a ratio. Steep hill upwards expressed as a passenger 25%. So likewise, we are using this kind of the information. So what is the PIR theory? So according to this theory, the total reaction time of the driver is split into 4 parts, where time taken by the driver's fault. So one is the perception, intellection, emotion, volition. So perception means it is the time required for the sensations received by the eyes or ears to be transmitted to the brain through the nervous system and spinal cord. In other words, it is the time required to perceive an object or situation. So we need to alert about all these kinds when we are observing one object at the time what we are going to do. So we need to maintain like this. So next, intellection time. It is the time required for understanding the situation. So we need to understand the situation when we are traveling on the road. Suddenly something has happened. We need to maintain. We need to take all kind of the precautions, everything. For example, here, decision side distance model. So decision distance and time, and action distance time. So visible, driver sees, identify the hazard, decides on action, initiative action, completes maneuvers. So when we are taking good decisions over there, then we can overcome from the accident, everything. And emotion time. It is time elapsed during emotional sensations and disturbance such as fear, anger, etc. with reference to the situation. So with reference to these kind of situation, therefore the emotion time of a driver is likely to very considerable and depending upon the problems involved. So this has happened. And next, violation time. Violation time is the time taken for the final location. So this kind of information is going on over there. So next, so analysis of SSD. So generally, what is stopping side distance in the sense? Lag distance plus braking distance is known as stopping side distance. So we can say log distance. The distance traveled by the vehicle during the total reaction time is known as log distance. So how total reaction time is there? That one is the lag distance. Lag distance is equals to V into T. The speed of the vehicle, T is total reaction time. Vt is equal to some case 0.278 Vt. Can use like this. And this is the braking distance. The distance traveled by the vehicle after the application of the brakes to a dead stop position, which is known as the braking distance. And here some picture is there. How long it takes up stop drivers on the average family car. So guys, this is a speed 40 kmph to the 110 kmph of left side of the column. And coming to the next reaction distance. So reaction distance is the 17 plus 21 plus 25 plus 46 plus. And coming to the next braking distance dry road by braking distance wet road. So we are using here. So then we can calculate here stopping distance. So for example, we can calculate dry road for the 40 kmph. The reaction distance is 17 plus braking distance dry road is the 9. So that is a 26 meter. So 26 meter ahead we need to take the reaction. So then the stopping distance is correct. For example, then here wet road. So 17 plus and here 13, that is the 30 meters. So more distance is required on the wet road, so compared to the dry road. According to the, we need to take, for example, 110 kmph is there now. So 46 is the reaction distance in meters, and 67 is braking distance in dry road, and 97 is the wet road. So that distance is the 113 meters and 140 meter. So derivation is there here. When according to that we can calculate the kinetic energy at the design speed of v meter per second will be. So there is a kinetic half mv square, and the weight, unit weight is there, wv square by 2g, and here fwl is equals to wv square by 2g. Here from the above line we can take ww, when we gets cancelled here, then l is equals to v square by 2g. F is coming to the right side. So we can say, according to the, we can get these values. Here f is the design coefficient of the friction. So 0.4 to 0.35 depending on the speed, there is a 30 to 80 kmph. Acceleration is 9.81, we know very well. So stopping distance we know, log distance plus braking distance we know. So SSD stopping distance is equals to log distance is Vt, and braking distance is V square by 2gf, we know very well. So if speed is V kmph, then stopping distance, so in place of Vt, already we have discussed in previous slide, that is the 0.278 Vt plus V square by 254 into f. So that is, we have taken the value here. So at the same time, stopping distance at the slopes, when there is an ascending gradient is positive n percentage, comparatively gravity adds to the braking action, and hence the braking distance is decreased. So two components is there, positive is there and negative is there, upside gradient, ascending gradient, and as well as the descending gradient is there. Ascending gradient we can take is the positive way here. So we can say the braking force is equal to the W sin theta, we can say W tan alpha, W sin alpha and W tan alpha. So we can write here capital W n upon 100. So here equating kinetic energy and work down. So Fw plus Wn by 100 into L. So half W V square by G. So in this case we can take common of W from both sides. So here L is equals to braking distance, L is equals to V square by 2g into this f plus n by 100 is the common from the left side portion. It will come to the right side, then it is by f plus n into 100 we can take. So this is a descending gradient, guys. The previous is the ascending gradient, as the same formula. Here the descending gradient is the negative percentage. So L is equals to V square by 2g into f minus n by 100. So while taking both, while taking ascending and descending gradients, we can say stopping distance is equals to Vt plus V square by 2g into f plus r minus 0.01. So we can say this one is the stopping distance. While V is the kmph, if the value of V is the kmph, then we can take here in place of Vt, that is a 0.278 E suffix t. So stopping distance is equals to 0.278 Vt plus V square by 254 into f plus r minus 0.01 n. So this is the stopping distance. So at the tabular form is there values. The stopping side distance values for the different speeds. So design speed is 20, 25, 30, 40, 50 up to 100 is there, and safe stopping side distance for the design in meter, that is a 20, 25 to up to 180. Depends upon speed, it will take the stopping side distance. So this is the information. Thank you.